Okay, would you all, turn to the page of 185. Okay, look at equation 6.14. I'll see whether I have this. Some of you may not have the textbook. See whether I can have something from here. Okay. Okay, this is the example. Let's show this one, okay? Okay. This is about the demand for Brazilian coffee. And what's the X variable? Now we have the real price of Brazilian coffee. So it's the price, right? And Y is the demand. Or we can say the consumption. Okay? Then number 2, real price of tea. What is this? What's the role of these variables? Since we're working with the demand of Brazilian coffee, why do I have the price of the tea? Very good. In economic theory, this is what we call substitution effect. Means what? Not everybody drink coffee. Although a lot of people drink coffee. But there's many people drink tea too. So tea is the substitution of the coffee. Therefore, the price of tea will play the role to the demand of coffee. Okay, so this is what we call price effect, and this is what we call substitution effect. How about this one? Real disposable income. This is what we call income effect. So what is your expectation for all these X variables to the Y? When the price of Brazilian coffee go up, then the demand will go down, so negative. This is the demand law in economics, right? And what's the second one? If the price of the tea goes up, then since the price of the tea go up, less people drink tea than drink coffee. Will more people drink coffee? So it's positive. So this is positive. And disposable income, if is more wealthier, then you drink coffee because, maybe coffee is still expensive than water or other drinks, right? Okay, so this is positive. So negative, positive, and positive. All right, look at this one. The author didn't provide the data, just provide the results to all of us. Okay, look at these equations. This is the demand for coffee with price of Brazilian coffee and the price for tea and the income. So this is the result. First of all, let's see the result. Does that follow our expectation? First of all, see the sign is all the output follow our expectation? No. the first one, our expectation is negative, right? And these two are positive, so this two is okay. Then, where can you see from the t-test? We just check the theory, right? So second one, t-test. What's the t-test tell us? By the way, can you see from this t statistic, and if you don't check the critical value, can you sort of guess whether it is reject the null hypothesis or do not reject the null hypothesis? Can you tell? I can tell you the general rules, okay? Look at this one. Let's look at table first. Table B1 from our textbook. What's the critical value from these t distributions? We need to know the degrees of freedom, right? So if we have different degrees of freedom, the critical value will be different. Then, did you see the degrees of freedom is infinitive? Look at the infinitive. Okay? This means that the table just provides 120 degrees of freedom. In fact, if you can get all these critical values from computers. Okay? But if you don't have computer with you, this table can help you somewhat. But if you know that the degrees of freedom is infinitive, means the sample size is huge. Okay? Then look at all these numbers. Okay? Like if you have the two tests for 5%, the number is 1.96. Okay? No matter, since it is two-sided, therefore positive or negative. Okay? And usually, since we always use 5%, but not really strict to the 5%, we can use 10% too. Okay? So generally speaking, if you look at the t-test, this is t-statistic. This is not critical value. You have to use this t-statistic to compare with the critical value with the specified alpha level, right? So for example, if we're using 5% for two-sided test, the critical value is 1.96. It's pretty close to 0, pretty close to 2. So generally speaking, if you look at t, if it is greater than 2, most likely the greater than the critical value. If it is less than 2, like this one, 0.5 definitely falls on the non-rejection region. If that's greater than 2, most likely will fall on the rejection region. So it means these variables are important. This is just general rule, but you have to really specific go through all those critical values if you know the degrees of freedom. And even more smaller, like 1%, for two-sided for 1%, it should be up to 2.576, right? So if you have the numbers which like this one is greater than 3, definitely the positive relation, it is significant. And this one, you really have to check because this is in the borderline. And this is definitely, do not reject the null hypothesis. Okay, this is the general rule. I will, first of all, look at all this result without checking the critical values. Okay, so in this way, this one definitely. This one, do not follow the expectation, and this is not right. Okay, but according to the theory, these 3 variables are important. But we may not, still go back to the same questions that I may not, using this, or most of us, especially the beginning researchers, okay, we really focus on the output better than the theory, right? We like to see the output, and based on the output, we make the decision from the output. This is totally wrong. But we make this kind of mistake pretty often. Okay, so in this case, although the theory tells us these three are important, but look at the equation 6.15. Since this is not significant, maybe I'll just try to eliminate this one and use this two. Okay, so this is what we have for 6.15. What does this tell us? What is this result? By using t-statistic, these two are significant, right? Then let's see the adjusted R-square. Do we see adjusted R-square? This one is 0.6. The first one with PPC is 0.6. Without it, increase a little bit by adjusted R-square. Okay? The moral of this example really tells us that if the theory, really tells us that the demand law, the price of the Brazilian coffee, is very important factors to affect the demand of Brazilian coffee, then even it is not significant. Even it is not significant, we cannot neglect of these variables. But the problem for this equation is the sign is not correct either. Okay, then this is an indication. If by theory, if this variables is very important, and after you do the estimation, then you find out t-statistics is not didn't pass the hypothesis testing, although also the sign is not correct. Most likely you are omitted important variables. So do not drop off this one. You need to go back to the theory and find something which is still important for the demand of Brazilian coffee. So never drop this off. Although you see the statistics, although the hypothesis testing is not good, the result of hypothesis testing is not good. Also, the sign is opposite. Most likely, you are omitted this important variables. So look at the one, the author. Let me see. Okay, look at this one. This is the original 3. Okay? There's another one called PCC. What is this? This is the price. Instead, add the price of Colombia coffee, PCC, to the original equation. So we add one more. So our original model really omitted this same variable, this variables. So this is also what? This is also the substitution effect. Because Brazilian coffee and Colombia coffee. Anybody know the difference? Huh?
Colombian is better.
Oh, Colombia is better. Oh, really?
No, I don't know.
Huh? You fool me.
But yeah, I would say that probably, I think Colombian chocolate is better. Cacao coffee is better, so probably coffee is better.
Oh, okay. Okay. I really don't know, but any kinds of coffee, when it is, it drinks. I like to drink coffee. Okay. So if we provide another variable, it's called Colombian coffee, the price of Colombian coffee. Look at this one. After I add these variables in, then look at all the signs. This two still follow the sign, and this significant, and also, since this is a substitution effect, so it's positive. And did you see this? Turn back to the negative relationship. Okay? You see the story here? This really means that do not use the output to make the decision. Do not use this output to make the decision to reject those X variables which is stated in the theory, and it's important variables. If I follow the criteria, maybe it passed. I think it passed. But it is not correct. So this is the reason we say this is an illustration of misuse specification criteria. So specification criteria is not everything. Just go back to the theory and choose the better X variable. Any questions about this? And if we're using different specification criteria, this is different from hypothesis testing. Hypothesis testing, we have three approaches, right? If we have this two-sided test, we have a p-value approach, we have critical value approach, and confidence interval approach. And these three approaches get to the same conclusion. But the specification criteria maybe end up with the different result. Okay? So usually, if most of the criteria get to that direction, the answer, then I'll follow the one. Even some of them does not get to the same conclusion. I'll choose the most of the criteria, the result for most of the specification criteria. Okay? There is no solution. There's no one solution in the world, right? So this is 6.3. Any questions so far? Okay, then there's one topic from book 6.4 is called specification searches. Okay, this is talking about many of us, okay, especially when you do the thesis, okay, you may, since omitted variable is most important, most serious problems, then include the irrelevant variable, right? Okay, so for the beginners, I think you're afraid of miss factors, important variables. Therefore, you will include all, it's possible, as many as you can. Since include an irrelevant variable is not that serious, then omitted variable. Therefore, we are tended to include as many as possible from the theory. And after that, you may do the searchings. What do you mean by do the searchings? Didn't I tell you that we have AIC, BIC, something like this one? So you can do the combinations from all these X variables, then check, see what's the best. Will you do that? I think most of us do that. But the author tells us not. Do not go fishing. This is like go fishing. Always back to the theory. Choose the most important one. Nobody can choose all of them, but choose the most important one. And especially we have to follow some rules or practice. Okay, look at page 188. Okay, there's a rules we have to follow. Let's see whether we have this one here. Okay, here. Rely on the theory rather than statistical fit as much as possible when choosing variables, functional form, and the like. Always rely on the theory rather than statistical fit. Did I say that we're using so many variables and do some of the combination? Since we're using computers. Let computer do all these combinations and just go fishing. This tells us that rely on the theory rather than statistical fit as much as possible when choosing variables or functional forms and the like. Then second one, minimize the number of equations estimated. Minimize the number of equations estimated. Okay, don't use a lot, then choose you think the best one based on the data you have it. Maybe using this data, that model is the best. This is what we call the statistical fit. But if you have the different data set using the same variables, it may end up with the different story. So this is what we say go fishing. Okay, so minimize the number of equations estimated. Then, I'm going to talk about sensitivity analysis. This is really what we have to do instead of go fishing. Okay, the 3-1, review in a footnote or appendix or alternative specification estimated. This means that if you do some other models, you also need to review in your footnote or your appendix of the thesis. Then all alternative specification estimated show other models which you tried it. This is for honesty. Okay? All right. And let me see. And also, nowadays we using big data. We like to using big data, right? Then when you using the big data, you need to do data mining. This is really different branch besides statistical. Besides statistics. Okay? And data mining really involves estimating a wide variety of alternative specification before a best equation is chosen. And really data mining is different from the hypothesis testing. It's really different. So never mix this together. This is statistics. Okay? Data mining is a different story, and we are not talking about the data mining here, but you may have some other courses to do the data mining. So that's really different. Okay? And your data mining is not using sample. You're using big data. And they call this big data is the representative of population. They really consider, since it is big data, so consider it's a population. So if you consider it is population, there's no hypothesis testing anymore, because hypothesis testing is related to sample. Okay? So do not mix the data mining with the statistics here. Okay. The sensitivity analysis. You may, when you read those articles, okay, you may see very decent papers, research papers, do sensitivity analysis. Okay? So what do we mean by sensitivity analysis? The author tells us that throughout the text, you have been encouraged to estimate as few specifications as possible. However, academic journal articles often report multiple specifications. What's going on about this one? The author employ what we call sensitivity analysis. So what is sensitivity analysis? Sensitivity analysis consists of a purposefully running a number of specifications to determine whether the results are robust. You know this word, robust? What does that mean, robust?
It's like being stable and strong at the same time.
Okay, you use the different way, but you will end up with the similar result. Okay? So if you're using different model specification, then you still end up with the same answer. So this is what we call robust. Okay? And this words, purposefully. If you go fishing, you don't, I know. If you go fishing, really you want to have fish, right? But here we say go fishing. If I have 10 variables, then I use the sort of combination to get all different kinds of models. And we really, you just wanted to get the best result from the data you have it. You don't have any ideas about it. So we cannot say that is purposefully running a number of specifications. It's just whatever combinations. So the purpose of sensitivity analysis is to increase confidence in the result. Okay, so in the future, if you read articles, I have read many articles. They are doing all the main experimental models. Then later on, they provide any other sensitivity analysis to restart to maybe divide some groups or including something else, which is important for the relationship of the experimental X variables to the Y. Then it will end up to the same result. This is what we call sensitivity analysis, not just, go fishing for any other variables. There's a meaning on it. Okay? So do the sensitivity analysis instead of data mining or gold fishing. This is the moral of the story. Okay? That's it for chapter 6. Any questions? Any questions? How fast I go? I cannot imagine. I thought I may not have enough time for today for all of the materials. Then it just covered. Any questions? Or you wanted to start to working on the assignments? There's a data is already in the iLearnings. Download the data set. Okay, would you do that? Download the data set, then start to working with that, especially the second one, the BIOS. Okay? And you can ask any questions, And I'm going to cover chapter 7. Then, chapter 7, we do have a lab, which is the last assignment for this semester. Maybe it's the end of December. That's 2 weeks after next week. Then we're done this semester. How wonderful. Any questions? Okay, I provide one elective course next semester. This is the second half of this textbook. And if you're interested in, you can, take it. This is good for your thesis, I think. I think this just one semester is not enough. We really haven't go to the details yet. This is just the beginning from chapter 6. It's just the beginning. And believe me, I will make it very clear to every topic. Okay, I don't want my students to learn in a foggy way. Do you like to see those one with just one variables, then auxiliary regression with 2, and see the bias? I didn't really show the numbers this morning, right? This one, I didn't really show the numbers. Do you like to do this calculation? No, you have to do this one in assignments. If you do the one variable models, and the correct one is 3 variables, then you have to see how all these 2 variables affect the coefficient of just one variable model. And this one is from here. So you have to, we have already had this one, we have to run this one. So let me see. I may have that one. So I have this one, and this one, let me have this one, and let me see what I have this one. No, I don't have it. No, I don't have it. Well, let me run it now. So I run it y with n only. Y and n only. This is equation 7. Okay, and I need to run the other 2. So this is 7, this one. So I have to run with the one with P and N and I and N, right? P and N. Open this equation. This is equation 8. So this one here, and also I with N. Open equation, this one, and limit 9. Okay, which is here. Okay? Now, look at this one. If the correct one is negative 9074, but now with just one variables, and then the coefficient is negative 1683. There's a difference, right? This is a bias. Where does this bias coming from? Where is this bias coming from? So this means that, let me write it here, okay? Since I just used this, so gamma 1 minus the beta 1 hat, which now is negative 1683 minus negative 0.9074. So what is this? Is this one? Okay? And where is this coming from? From this one plus this one. Means I'm using P as since these are 2 omitted variable, and this N is 1 variable included. So P, and I have to run this regression in order to get alpha 1 and omega 1. And this is this numbers and this numbers. Okay? So this one will be alpha 1 is using P and N. Okay? Which is these numbers. And beta 2 is 0, 4, 6, 6, 8, something, okay? And this one, gamma omega 1 is this, right? I'll put this one. Since this is using I with N. So this is negative 84, 48 something times this one is 1.28, 7923. Check whether this result will end up with these numbers. Somebody calculate for me? This is, really this positive and some negative here. Huh? Exactly the same? It should be. Maybe, if you have some decimal places, it will end up with a little bit different, but it really doesn't matter. Okay. All right. So this end up with the same as this one. So if you do your option either A, B, C, D, E, F, this kind of combination is different. Okay? Okay? Is that clear? No problem with assignments, right? Just work as early as possible, okay? In case you bump into the questions, okay? All right? All right, that's for today.